Hey everyone, this is the SolidWorks Animation Zero to Hero presentation. First things first, massive thanks to Amy for making sure this is all set up and everything. Fun fact, actually, I was Googling where Polk County is, and I found from the Wikipedia page that there's like 12 places in the USA called Polk County. So I have to add the Florida at the very end. So yeah, that's a neat one. So, just a quick intro about who am I. I've been using SolidWorks for about 8.5 years right now, and throughout those years, it started as a fun thing, just like a tool to create cool stuff and stuff like that. I didn't have anything like mechanical engineering in my mind. I was like 14 at the time, and this part of my early use of SolidWorks is what we're going to be delving a bit more into today because yeah, after that, I got into engineering and I just graduated, by the way, from engineering. But before that, before you use SolidWorks as a mechanical design tool, I used it as a design tool in general. So I made like silly designs like Shaun the Sheep and stuff like that in SolidWorks. And the next step from that is to animate it, to look at it in different ways and like a video, right? So this is what we're going to be talking about today. Forget about all of this stuff on the screen. This is the important thing. I used to love SolidWorks because I used it when I was small, and this is what I'm going to share today. Okay, so quick intro, by the way. These guys from the core podcast, Kirby and Johnny, I was on their podcast a couple of weeks ago. So if you want to know a bit more about my background with SolidWorks, you can scan this QR code. It's going to take you to the live podcast that we had together. Other than that, let's get started with the agenda for today. So we're going to start by just an intro of what motion studies are. And there are multiple types of motion studies in SolidWorks. So we're going to take each one of them and then start talking about what differs it from the other types and when to choose that type instead of the other. And then each type of those, we're going to take a bit like a deep dive into it and talk about the different techniques in that type of motion studies. And at the very end, we're going to talk about some tips and tricks while you're exporting or saving your animation outside of SolidWorks. Okay, so for starters, when we talk about motion studies, before we know what motion studies are, let's talk about why we actually care about using motion studies. And the first thing that comes to my mind is eye-catching. I mean, look at this animation over here. You might have seen it before because it was actually shared on the SolidWorks social media channels a couple of times on different platforms. And I created this a couple of years ago, I think like 2 or 3 years ago. And the model itself, it wasn't really that hard. But the cool thing about it is the way I presented it. You know, when you scroll on social media, like Facebook or Instagram or something, and you see a design, it's usually like a screenshot or something. And yeah, it's okay. But when you see something that's moving, that immediately draws your attention and you just have to look at it. You know, it's like scroll stopping. So this is the first thing that comes to my mind. The next thing is that sometimes models require to be seen in motion to be able to be fully understood. So for example, this mechanism you're seeing on your screen right now, while it's still, you don't actually know what it does until I actually start making it move. And when it's in motion, you now understand, okay, so it's transferring this like rotary motion to reciprocating linear motion and so on. So the full details about the model will only be revealed to you when you see it in motion, right? Okay, so what about the third thing, which is sometimes your model is a bit too complicated or a bit too complex, or it's got like intricate details that seeing it from one view is just not enough. And in that case, what you need to do is actually look at it from different angles, whether you need to like zoom in a bit from a certain point or look at it from a different angle at all. Like for this example, from one side it says Yahya, and from the other side it says Kedr. Okay, so looking at something from different angles, zooming in, stuff like that, that's all things that you can do with motion. A still image will never give you the ability to do something like that. Okay, so these are the main reasons, but that's not all. So for example, you can have fun with motion studies. This video you're going to see right now was 100% created inside of SolidWorks. Let's take a look. Okay, and remember, no like After Effects, nothing was like used in Camtasia or anything. This was 100% created inside of SolidWorks. And if you don't believe me, well, here's the side by side. I created like a boss extrusion, put this image, like a screenshot on it, like a decal, and then animated the camera movement so that it would do this zooming and stuff like that. And this, obviously, when the product definition team of SolidWorks created the motion studies, they didn't have this in mind when they created it. But I'm just showing you that something like this, when it can be used to create something like silly as what I've just shown you, that means that it can also be used to be to create like great things at the same time. Since it can handle something like that, it can handle something like specific and engineering related and stuff like that. So enough of that. Now let's talk about motion studies for real. Okay, let's talk about these two different types of them. So technically, there are three types of motion studies, not just animation and basic motion. There's a third type, which is motion analysis. You might have heard of it, but we're not going to cover it today because actually two reasons. The first reason is motion analysis is, it's like striking the line between the being just like animation and just moving your components around and being a full-fledged simulation on your model. And the other reason is it doesn't come with every license of SolidWorks. So whatever license you are using, whatever edition you're using, whatever release of SolidWorks you're using, you're going to find animation and basic motion. It comes with SolidWorks Standard, it comes with SolidWorks Premium, Professional, Ultimate, a Student Edition, Commercial License, the Maker's Edition, everything. The third one, which is motion analysis, that only comes with SolidWorks Premium. Okay, so that's why we're not going to cover it today. Okay, so let's talk about animation and basic motion. What are the differences between both? So the first thing we're going to talk about is what they are based on. When it comes to animation, it's based on something called a key point. And we're going to talk about a bit more about what key points are in a moment. But just think of key points as like still frames in time. So if I would like freeze time and save that frozen moment in time, I would call that a key point. And then do some changes and take another like screenshot or capture and call that another key point. And all the software is going to do is move from the first key point to the second key point. And that movement between both of these key points is called interpolation. Okay, it's like the transition from one key point to the other. And that transition is 100% done by SolidWorks, but you can actually influence it a bit. And we're going to talk about that as well. But this is the first type, which is to define still moments in time and to ask the software to move from one moment to the other. The other way is to define it based on a motor. So you define a motor, whether it's like a linear motor or a rotary motor, and set some parameters and just hit run, and the software will calculate that for you. Okay. And on the other hand, when it comes to basic motion, it's depending on things that are like real life, physics-based, things like gravity, things like contact between bodies and stuff. So it's got a bit of a simulation in it, like a hint of simulation, but not full-fledged like motion analysis. And because it's like got these small hints of simulation, it's way faster when it comes to computation and calculating when compared to something like motion analysis. And the cool thing here is you only define like the overall parameters and settings, and you let the software amaze you with what your parameters would mean when regarding your design. So the conclusion I want to get to here is when it comes to animation, you already set both the inputs and the outputs, and all the software has to do is just move from one certain condition or one certain frame to the other. When it comes to basic motion, you only specify the inputs. You tell it, okay, I want the gravity to be in this direction. I want contacts between these components and so on. And you don't know what the results are going to be. You can have an idea, but you won't know for sure until you actually hit calculate and the software would give you the output at the end. Okay, so this is basically the difference between both of them. Now let's talk about animation in a bit more depth. But before that, let's talk about key points, because as I said, key points are the main basis of animations. So let's say, for example, we've got two states. The first state is all of these cubes set on one side of this runaway, and the other key point is all of them at the end. Okay, so this is the first key point. This is the second key point. And what I want to do now is change the interpolation, change the transition from the first key point to the second key point. And you notice these five titles or five types of interpolation. I want you to look carefully, not at the title, but at the boxes themselves, how they move. So when it comes to something like linear, it's got linear speed. It's not changing at all. Ease in, it's like slowing in and then speeding up. You've got ease out, which is the opposite. It's going a bit fast and then slows down at the end. So I was talking about the interpolation, how different types of interpolation would change how the movement or the transition would look from one key point to the other. And looking at this video over here, you're gonna see you've got like the linear, the snap, the ease in and the ease out, all of these. So linear, just the same speed throughout the whole time. Ease in and ease out, it just slows down at the beginning and goes a bit faster at the end, or the opposite. And snap, it just stays the same throughout the whole duration, and at the very last moment it just goes snap and jumps to the next key. So these are the different types of transitions that you could use. Okay, but in all of these 5 cases, you still have the exact same first key point and the last key point. Okay, you're just changing how you move from one of them to the other. With that out of the way, now let's talk about the different types or different techniques of creating your animations. And the first thing is like the most basic thing, which is basic dragging. Okay, so this is the result that we want to do at the very end. We want to do this animation over here. You might have seen this before. It's a debunk of a infamous chocolate trick, which is like you cut it in a certain way and shuffle some pieces around, and somehow you end up with an extra piece. And obviously, as you can see here, I've got the white border, so you see that the extra piece is actually distributed along the bottom line over here. But anyways, we want to create this inside of SolidWorks. So let's jump right into SolidWorks. I've got the assembly here, and now let's create a new motion study. And we've got this interface, this bottom part over here. Let's talk about this. So first of all, over here on the left, you've got like a stripped down version of the feature tree over here. Right here, it's got only the things that you could control or you need to control inside of the motion study. So for example, you've got your mates folder, you've got the components, but here, if I open one of these components, you won't find the features. Instead, you're gonna find moving them, exploding them, changing the appearances, managing the mates, things that you would actually need to use inside of the motion study. Okay, you'll also find things like the cameras, the lights, the scenes, and so on. Now, jumping over here to the middle section, or the section on the right, this is the timeline, where here we've got the time bar, 0 seconds, 2 seconds, 4, and so on. You can like manipulate everything with respect to time. And on the top over here, this is where you've got the controls, the tools to change these things. And we're gonna use these tools a bit more while we're going through. But let's talk about the most basic thing, which is basic dragging. We're going to drag components by hand or by the cursor to change their position. So let's say I'm going to go at the 2-second mark, and you notice this this line over here. This tells me that right now I'm at the 2-second mark. Any changes I do will be saved at the 2-second mark. So let's say, for example, I'm just dragging this component all the way down here. The moment I release it, look at this rhombus shape over here. This is the key point. And this green bar, it's a change bar. And the green color indicates that this is a change in position. So in that case, I know that this component called thin long, for example, is changing its position from this key point to this one, okay? Let's say I go to the 4-second mark, and then I want to drag this component over here. And now I've got another key point, and so on. I can keep doing this on and on and on, like moving these components by hand and adding more and more key points. And let's say at the 8-second mark, I want this component to go all the way back again over here. Let's say something like this, okay? And it kind of looks okay, but if I zoom in a bit, you're gonna see that it's not actually, I've got some interferences, it's not really precise. It's okay for doing it like in a quick and hacky way, but if you want to do something like precise and manageable and something that you can change later on, we need to actually use the other way, which is to define it by mates, okay? And the cool thing here is, let me just start a new motion study and reset everything. I've already got mates in place to do everything for me. So if I open the mates folder, you can see I've got these limit distance mates in place. And the cool thing about limit distance mates is you set a minimum limit and a maximum limit, and the component is free to move between them. So it's, since this has a value, a numeric value, I could control that. So let's say, for example, at the 2-second mark, let's change this limit distance mate. Let's say I'm gonna double click on it. Okay, And in this case, let's change the value of it myself. SolidWorks is taking a break for a moment, just a sec. Yeah, I think SolidWorks wants to crash, so let's hope everything works smoothly as possible. You know what? It's hung for a bit too long. Let's close SolidWorks and run it once again. I mean, it's gonna happen on a live demo, right?
It always happens.
Yeah.
I had it happen to me 3 times today with students.
Ooh, that's fun.
Oh yeah, with the smart board, which when I having problems, you know what the kids I call it, and the kids say it now, the dumb board. Because it literally all of a sudden decides it's going to do its own thing.
Yeah.
So when it does that, I'm going, okay, dumb board. And the kids are going, yep, it's a dumb board. I said, yep, it is.
Wait until the board have its own brain with AI.
That's it. Let it have its
That's
own
more
brain.
scary.
Although it already has its own brain now. It's like, I don't want to work right now, so I'm going to make you mad. All right, we got it now. Yeah.
We're back. Let me just reopen the model.
All right, great.
And we're good to go. Okay, we're back. So once again, what I was just showing is, let's do this once again with mates. I'm going to stop at the 2-second mark, and I'm going to open my mates folder, and over here I've got this limit distance mate. So what I want to do is just change this distance. If I right click and go edit dimension, or if I double click on it, I'm going to get this this dialog box as usual. I'm just going to modify the dimension. So this is just as if I'm editing the mate regularly, you know, and here it is, the key point, it's added. And now if I hit calculate, it's going to calculate that movement for me, and it's going to show me, okay, it's moving now downwards. Okay, but now I know exactly where it is precisely, and I can go, let's say, at the 4-second mark and use this one. So I've got this other limit distance for the horizontal movement, and I would use that as well. And the exact same thing, I'm just going to change it. And I've also got the movement over here. Let's say I also want to change this big part. I want it to move this way. So here's a cool thing. If I change it right now, you know, the changing is going to happen from the 0-second mark to the 4-second mark. You know, let's try it right now. Let's just edit dimension and change the value. And just like that, as you can see over here, the change bar is throughout the whole duration. What if I don't want that? What if I only want this one to start moving after this part is cleared away, after this one is at the 2-second mark? I can just simply click this and drag and release it at the 2-second mark. And just like that, I've got it over here. So the changing is only happening from 2 seconds to 4 seconds, but from 0 to 2, this big component over here is not moving at all. And I can keep moving on and on with this. So let's say at the 6-second mark, I want this component to come back again. So this mate over here. But if I change it right now, the change is going to happen all along this duration. So instead, let's say I can come over here, Control C to copy, and then when I come over here and paste, Control V, you see I've got the same exact key point. Therefore, there is no changing between them, so there is no change bar. So next time I go to the 6-second mark and edit the dimension and change something, it's only going to add the change bar from the most recent or the previous key point, which is in this case the one I just pasted right there. So you see now I've got it all set up. The last thing I just want to do is to hide one of these components, this extra component over here called delete me. Let me just right click, hide. And just as you expected, this is also a change. So I've got another key point over here. And now when I hit calculate, as you can see, it's all moving just as expected. These components are moving down, this is moving up, and so on. Okay, so this is just an example of what you could do with Mate. And now, if I zoom in over here, you notice that I've got this precise movement where this component is exactly where I want it to be. No intersections, no issues, nothing at all. Okay, so this is one of the ways you could actually animate them, which is to move components around. Now, that example was on an assembly. Okay, but that's not everything, because you can also do this for components. So it doesn't always have to be animations and motion studies for your assemblies. So let's take another example for now. We saw how we can actually change the position of certain components. Now let's change the position of the camera, change the views itself. And this is the model I showed you earlier, which is from one side it says Yahya, and from the other side it says Kedr. And in this case, you can come over here and go insert and add a new motion study, or right click at the motion study over here and just hit create new motion study from over here. Okay, and now that I've got the motion study, let's say I want it to start looking from over here. So this is the first key point. Maybe I'm going to zoom in a bit, something like that. Okay, and at the 2-second mark, I want it to look at the other direction, maybe like this, for example. But there is no key points getting added. You know, I'm doing all these changes in the views, but no key points are getting added. And this is because by default, views are things that you would actually need to manipulate, not just to use them in the animation, but to look around and to select things and stuff like that. So we've got an extra option over here under orientation and camera views. If I right click, I've got this option called disable view key creation. These are keys specifically for views. Okay, so right now it's actually checked. So if I uncheck it, now if I change the views, let's say something like that, now I've got this white key point over here, which indicates a change in the view itself. And now if I hit play, as you can see, it's now going to do all of this change. So let's say I want this to actually be the very beginning. All I can do is just drag this to the very beginning, and that's it. And now at the 2-second mark, and can get it to this position. And let's say I want it to be a looping animation. I can bring it to the 4-second mark and come back again to this. And now when I hit play, it's going to go from the first key point to the second and back again. And that looks cool, but I want this to loop, not just to move once and that's it. So in that case, over here, I've got the playback mode. Instead of just doing it normal, I've got other options, loop, reciprocate. And in this case, I want it to loop because it's going to be like going on and on and on. And in this case, when I hit play, it's just going to keep going from Yahya to Kedr and back again over and over and over until you hit stop. But okay, it looks good and everything, but there's this harsh stop it does every time it shifts from Yahya to Kedr and back again. You see, right now, it's got this sudden jump. And that's because the default transition or the default interpolation is linear. And when it's linear, it's got like a constant velocity in one direction. And in a split second, it's changing that velocity by 180 degrees. It's the negative value of that velocity in the other direction. So in that case, I want it to be a bit smoother. So to change the interpolation, all you have to do is just right click on the key point, or maybe control select multiple key points. So I've got this one and this one selected, and then right click, you've got interpolation mode over here. And from here, I can select anything. So let's say ease in and ease out is a personal favorite because it starts slow and then speeds up and then ends slow. So it's really cool. So let's now hit play from start. And now when you look at it, it's very smooth, and you've got this smooth transition from one of them to the other. And unless I actually show you, you won't actually know exactly where's the start and where's the end, because it's all like fluid motion. Okay, there is no like sudden jumps or anything. So this is a way to manipulate the views. But let's say, for example, you wanted to make it a bit more precise, okay, just as we did with the mates. So in that case, we can use cameras. And in case you've never used cameras inside of SolidWorks before, when you go over here to the display manager, so over here at display manager, you're usually met with the appearances. But if you go to the third one, which is the scenes, the lights, and the cameras, from over there, you can right click on the camera folder, hit add camera. And now you're met with this split screen situation where over here on the right, this is the camera view. This is what the camera sees. This is the camera output. And over here on the left, this is the model view. Okay, so if I like look at it from different angles, I've got the model, I've got the camera, and I've got this yellow ball over here. If I move this, this is the camera position. Okay, this is where the camera is, but it's always looking at the same point. And that point is specified by this red dot. So if I move this red dot around, this is where the camera is looking at. And personally, I prefer coming over here and checking the show numeric controls option, because that gives me even better control. And let's say the target point, which is that red dot, I want it to be at the origin. So I'm just going to select the origin real quick over here. And there it is, 0.1 at the origin. And when it comes to the camera position from over here, I've got the distance, so I can change this to make it nearer or further. I've got the longitude and latitude. I can change it, let's say, to like 45 degrees. And this one, let's say like 5 degrees over here. Okay, so 45 degrees over there. If I change it to negative 45 degrees, it would be on the other side, and that's numeric control, right? Let's say this is way too far. Let's change it to like 300 millimeters away, and that looks cool. But you know, the aspect ratio is a bit off. So if I scroll all the way down, I've got here the perspective. I can turn it on and off if I want to. But the main thing is, I've got even control over the lens of the camera. If I want like a wide angle, I've got that. If I want like a telephoto, which is like a zooming in angle, I can also get that lens. And I can use a custom angle and just change those manually. In this case, let's go with something like a standard. Yeah, that looks good. But the aspect ratio is what we're here for. So you've got many options to choose from. I would actually go with 16:9. Since this is the ratio most of the phones and cameras and displays would actually be using. Okay, so yeah, that looks cool. Maybe actually zooming in a bit more on that. So let's change this to like 250 or something. And that looks cool. I'm gonna hit OK. And now I've got my camera. Now let's use that inside of my animation. So if I go over here to my motion study, I can delete all of that, go again to the stop position. And now I want to tell it to use that camera I just created. All I have to do is just right click on the very first key point in the orientation and camera views. And I'm going to say, okay, use the camera view. But since I've got multiple cameras, I'm just going to choose the one I just created, which is camera 2, hit OK. And just like that, I'm now using that camera inside of my motion study. Okay, so with that, all I have to do is now just change the parameters of that camera throughout the animation. So if I go to the 2-second mark and open this folder, I've got camera 2 over here. I can just do the same thing, right click and hit properties, or just double click on it. And all I've got to do right now is just change this from negative 45 degrees to 45 degrees. And I'm now looking at it from the other side. Okay. If I want to, I can just change the orientation and positioning a bit better. But anyways, this is what we're going to do it right now, like quick and dirty. And I can also copy the very first frame, paste it at the 4-second mark. And now it's going back again with the looping animation from the start to end and so on. And the cherry on top, I'm going to select both of these. I'm going to change the interpolation mode to ease in / ease out. And now when I hit start, play from the start, now I've got this cool camera to control everything. And I've also used everything we've learned throughout the past couple of minutes to make sure that it looks good. Okay, how about that? So one thing to notice here is I've got multiple cameras, but the thing that tells me that, hey, this is the camera you're using is not the key points, by the way. It's actually that orange bar in the background over here. So let's say, for example, I come over here. I already have these key points for camera 2. I'm not going to change them, but I'm going to right click. Hey, okay, let's change the camera view to camera 1. Now look, now the orange bar is at camera 1. And if I play, it's not going to do anything because I haven't changed anything with camera 1. So even though I've got these key points set at camera 2, what defines which camera I'm using is this orange bar over here. Okay, so keep that in mind in case like you're doing some troubleshooting or you find any issues. So that was pretty much it when it comes to camera movement. We've seen how to change the positioning of certain components. We've seen how to change the orientation or where we'd look at that component. Now let's change something else. We usually at the very end, we'd start adding the good looking things, which is the appearances and stuff. But let's say we actually want to change those in our animation. So for example, I've got this component over here, multiple components actually in this assembly. And there are some intricate details inside of it that I can't see right now, but I want to show it in the animation. So what I'm gonna do is I'm gonna just start a new motion study, let's say at the 2-second mark, and I want to hide some components or maybe change their transparency or even change their color altogether. So these 4 attaching pins, I'm just gonna right click and change transparency, and that would make them semi-transparent. Okay, and I've also got this purple change bar over here to indicate that there's change happening over here. Let's say at the 4-second mark, this top half, let's make it like disappear altogether. Let's just hide it. Okay, and let's say at the 6-second mark, I want this bottom half to change from blue to, how about red? Because SolidWorks is red, so let's go with red. So I just right click appearance, and now I can change the appearance just as I change the appearance of anything. I've got this appearance manager over here. In the library, let's go with something cool. Let's go with like gold, maybe. So how about red gold? So I've got polished gold, and from here I'm gonna change the color to red, and just like that, I'm gonna hit OK. So I've done all these changes, and there's the key point as well. And you know, before I play it, let's say I want everything to reset back again. So the cool thing is, I can just simply copy all of these, hit Control, and go at the 8-second mark and hit paste, and everything is gonna go back again. But this one will start changing in 2 seconds. This one will go back in like 6 seconds. I don't want that. I want everything to work together. So in that case, I can just copy these. Let's say like after a second, everything like waits for that second. I'm just copying and pasting. So everything will stay still for 1 second, and then in another second, everything is gonna go back again to the original position. How about that? So now when I hit play from start, you're gonna notice the transparency here is changing for the 4 pins. This is going from blue to like purple and then to red and going back again. The top half is going to be hidden at 100% and so on. All of these changes are not changes to the camera or to the components, but to the appearance, to the display of those components. So the changes that you can do here are like a ton. You can say, for example, I've got this like phone that I want to show in different colors. Let's say you're doing an ad for iPhone, for example. You can change the color from red to green to blue, all in the same animation without affecting the original displays or animation or appearances in the assembly. So let's say I stop over here. Okay, I've got this weird purple color. I've got this semi-transparent and this as well. If I go back again here from the model tab at the bottom left corner to my assembly, everything is the same. All of these changes are only present inside of Motion Study 2 over here. So in that case, rest assured, everything you're doing is inside of this motion study. When you finish, you can save it out, and all of the original changes that you've made or the original settings that you've set for your model are still there. Okay, but at least you've got this cool animation to show. So with that being said, we've pretty much covered all of the uses of key points when it comes to animations. Now let's take it one step ahead. Let's talk about motors. Okay, and when it comes to motors, we've got 2 types of motors. We've got linear motors, which is like going in one direction or back, stuff like that. And we've got rotary motors, which is like going on and on and on in a rotary way. So let's start with a linear motor. And I want you to like sit back and open your imagination and think of motors not just as a real physical motor. It's something to like force some change in a certain direction, just as simple as that. So in this case, when it comes to a linear motor, it doesn't actually have to be like a piston or a hydraulic pump or anything. It just is going to force some change in a linear direction. Okay, so for example, in this case, I've got this piston that I've created, something like, it's actually not a piston, it's actually a pressure gauge. But anyways, so when this goes all the way down, this pointer would go all the way up. And if I hit rebuild, I've got this spring, which actually would rebuild as well. It's going to compress and decompress when this moves. So forget about all of that. What's the driving force here is just the linear motion of this component up and down. So that's what I want to do. All I want to do is just move this from up to down. So obviously I can just add like a limit distance mate and use that to drive the animation. But in this case, I'm going to show you a neat trick when it comes to linear motors that is going to convince you why this is actually the better option. So I'm going to start a new motion study as usual. I've got everything set up. all I need to do is just to add the motor. And if you go over here, I've got the motor button. And when I click on it, it starts the motor property manager over here on the left. Let me just minimize this from the collapse button, just to make this a bit bigger. And from here, I've got the rotary option or the linear option. Let's go with the linear. And here, I'm going to choose what the component is, where's the direction that it's going to go through, and so on. So in this case, I'm just going to say, okay, this is the direction. You can see this red arrow over here going upwards. So I'm just going to change that to go downwards. And this over here is where I would set what to move relative to. So in this case, this red piston is going to move relative to this white enclosure. Okay, just like that, I've got everything set up. And all I have to do now is to specify the parameters of that motor. So you can usually, when you see someone using the motor, they would usually go with the constant speed option. But that means that I've got to use the velocity. Velocity is like the distance divided by the time. And I don't want to do all of that math in my head. You know, I might be an engineer, but part of being an engineer is to know when to not use mathematics. So in that case, let me see what other options I've got over here. I've got distance. That's cool. I can tell, okay, move this distance in this time. So the software would calculate the velocity for me. That's cool. But what other options are there? Oscillation. That's super cool. That's actually exactly what I want right now, because when it comes to oscillation, that means that it's going to go and come back again. And that's what the oscillation is, right? And this is exactly what I want over here. I want this to go and come back because I've got this spring. So over here, I've got the displacement or the period of the oscillation. So I'm just going to enter that really quick. And here I've got the frequency. And when it comes to frequency, I know that frequency is 1 divided by the time. So I'm not going to do any math in my head. I'm just going to say 1 divided by, and let's say I want this to do in 2 seconds. So I'm just going to type that. If I want it to be like in 10 seconds, I'm just going to enter the time over here. I'm not going to do any maths in my head. So just like that, software is like understanding what I want, and I'm just going to hit OK. And remember, this time I set was 2 seconds. So all I've got to do is just end the animation after 2 seconds. So you see this, the very first key point over here, it's defaulting at 5 seconds. That's the default for any duration of a motion study you create. Obviously, you can make it a bit longer, you can make it a bit shorter. So in this case, I'm just going to end it at 2 seconds. Okay. Okay, what about the motor I just created? If you look at the tree over here, I've got the linear motor 1 over here. So that's where it's added. If I want to edit it, I can right click and edit it just as any feature I'm changing, and so on. Now, all I've got to do is just hit calculate and sit back and watch the magic. And note that this is going to take a bit more time than usual, because think of every single frame of this animation. It's actually rebuilding the whole thing, because I've got this spring, which is actually needing to be rebuilt on every single frame to change the geometry of it to the new position or the new shape. So in this case, it's going to take a bit more time, but it shouldn't take that much. So I think it should be done in any moment now. And yep, there it is. So now if I hit stop, it's got the 2 seconds. And remember, 2 seconds is the whole duration for the oscillation. So it would go in 1 second and come back in the other second. So if let me just zoom in a bit over here. Okay, if I step at the 1 second mark, it should be all the way down, and that's true. The 2 second mark, it's going to be all the way back up again, and that's true. And if I stop at any moment in between, as you can see, it's in between. So if I play from the very beginning, okay, it's going down a bit, and the spring is uncoiling or like getting spread, and then it goes back again and collapses, and so on. Okay, now this might be a bit choppy in the preview over here, but rest assured, when you save the animation out, it's going to be way cleaner than that. As I said, that's only because I've got this component that needs to be rebuilt every single time. Okay, so just like that, I've just used the linear motor in a different ingenious way, right? So let's talk about the rotary motor, because the rotary motor is actually the default thing, or the default idea of when I talk about a motor. So this, for example, is a case that I could use it. Okay, you would say, okay, where's the motor? I can't see any physical electric motor added to anything. And that's the thing. It's just a force to induce motion. It doesn't actually have to be physically there in your assembly. So what I want right now is to create a new motion study. and go back again and add another motor. But in this case, it's going to be a rotary motor. And the direction, I'm just going to choose one of these axes. And I've got this arrow over here to indicate direction. If I want to change it, I can flip it with a button. Relative to, so in this case, it's just floating in mid-air. So I don't actually need to use the relative to option. I'm just going to leave that as it is. And when it comes to the speed, it's set to RPM, revolutions per minute. How many revolutions is it going to do in 1 minute? And once again, I don't like to do math, okay? So I'm just going to say, okay, revolutions per minute, that means that if it's per second, it's going to be by 60, right? So if I enter 60 revolutions per minute divided by 60 is 1 revolution per second, okay? So 60 is the baseline. If I want it to be in 2 seconds, I'm going to go with divided by 2, which is like 30 RPM. If I want it like in 4 seconds, I want to be, so it's going to be 60 by 4 and so on. This is how I think when I do something like that. So let's go with 4 seconds. 60 divided by 4, hit enter and hit OK. And the same thing over here. I'm just going to end this the 4 second mark. By the way, you don't actually have to do this. If it's at the 5 second, or if you want the animation to be longer than the duration of the motor, I can come over here at the 4 second mark. And since I clicked, it's actually going to calculate till that position. And I can right click on that motor and just say off, just like that. And you'd see I've got this new key point over here. And this orange bar tells me that this motor is active all along in this duration, but after this 4 second mark, it's going to be off. Okay, so let me just also end this animation at the 4 second mark, play from the very beginning. And just like that, I've got the animation ready. You know, so this can keep going on and on and on. But since it starts and ends at the exact same position, I don't actually have to save it during multiple rotations. It's enough to do just one rotation and make the video loop and play on and on and on, whether it's like in a PowerPoint presentation or on social media and stuff like that. So that's actually a really neat way to make your whole timeline a bit shorter. So just like that, I've got everything set up, and yeah, that's it. So this is it when it comes to the motors. And that should be it with regards to techniques of animations. But actually, there's still one more type, or one more bunch of types, actually. So this is called the animation wizard. And from its name, it's called the wizard. So you might think of, ooh, this is something like, it's got some sorcery in it. And pretty much it does. So what it does is, in essence, it gathers multiple steps that you would have to do on your own, and it would just simplify them for yourself. Okay, you want to see how that works? Let's start with the simplest thing, which is rotation. And let me know in the chat if you've seen this end result before. But before we go to the end result, let's see how quick we'd actually get there. Okay, so I'm going to do a rotation animation, like a 360 view of the model. It's also called a turntable animation. And before I actually show you how to do it, I'm going to race the clock right now. So let me just open the clock real quick. And I'm going to start a stopwatch. And I'm going to see how fast I can do it in no time. So let me see. I've got actually a personal best. So I'm hoping to defeat that this time. Okay, so I've got this over here. And remember, this is going to be from start to finish. I even haven't started the motion study till I get the end result, which is the turntable animation. You ready? 3, 2, 1, start. Done. 6 seconds, 0.36. That's actually a personal best, by the way. So I'm going to explain everything I just did. But let's see actually what I got first. Before I play that, let me just turn on real view graphics and turn on the shadows, because that would be beneficial in this case. So when I hit play, I've got the turntable animation. It's going to go 360 around the model. And when you look at it, it's supposed to go around the y-axis. The y-axis is this green axis over here. But when you look at it, it's actually a bit to the side, and the y-axis itself is rotating, even though I'm supposed to be rotating about it. And what's going on here with the shadow? Sometimes I can see it, sometimes I don't. Sometimes I'm looking at the model from above, sometimes I'm looking at it from below. And that's the thing. This is like the quick and dirty way to create a turntable animation in like under 10 seconds. But when it comes to like a good looking animation, it fails miserably. So let me just first explain why it also fails, because that's not it. So the first thing I did is I went over here to the animation wizard button. I clicked on it. I've got multiple options. I went with the first one, which is to rotate. Okay, I'm gonna hit next. It specifies the axis of rotation, X, Y, and Z. How many rotations do you want? Clockwise, counterclockwise. Everything is like counterintuitive over here. And I'm going to go next. How long do you want it to be? Instead of like, right now I created it with like 10 seconds. Let's say I want the new one to be 7 seconds. Okay. And when should it start? From the 0-second mark. Okay. You would expect it to overwrite the previous one, right? Well, I'm going to hit finish and wrong. It actually overwrote. Actually didn't overwrite. It actually added on top of it those new key points. And now when I hit play from the beginning, it's actually just a mess. Okay, so no worries, you can delete it. You can delete all of these key points, or you can use another option, which is in the animation wizard. It says delete all existing paths. So thank God we've got this option, right? But before I use that option, let me just say, for example, I've got this animation. There are other things going on in the background. Let's say I'm just gonna like hide a couple of components. I might actually change like the transparency of some of them and so on. Let's say at the 6-second mark, I want these to be shown once again. And at the very end, I want this one to be shown. So I'm just adding and doing some changes other than the rotation, okay? Now, when I go and do this, delete all existing paths, next, and let's say, for example, I want it to be 5 seconds long. What you would expect is for it to only change or to only remove the orientation and camera view key points. But what actually does, it removes everything. So if you are doing this at the very end of your motion study and you've got everything done beforehand, don't do it, because it's going to delete everything for you. What you should do is actually select these and delete them manually. Okay. So now that we've known what the issues are with this type of it, what about the solution? How would I create a eye-catchy or like a scroll stopping turntable animation? And it's not going to be in under 6 seconds, that's for sure, but I'm going to show you a bit longer way, and I'm going to let you decide at the very end which is worth, okay? So I'm going to go back to the model. I'm going to make some prepping first. I've already created this plane over here. It's a bit above the model. Okay, let me just zoom out a bit. So I've got this plane, and on that plane, I've got a sketch. That sketch is just a simple circle, okay? That's it. Let me just show that circle. Like that. And now, you guessed it, I'm going to use cameras once again. So over here, right-click and add a camera. When it comes to cameras, as I said, I usually like using numeric control. For the target, let's go with the origin. It looks like the origin is way too down, so maybe I actually turn this off and manipulate it myself. Let's say like 12.5, so it's like in the midpoint, because I like everything to be centered. And when it comes to the camera position, this is the cool one. So in this case, I'm just gonna select this circle. And now this is the path for my camera. And since I've got this path, now I've got this cool slider over here. So look at this camera over here, okay? And tell me what happens when I move the slider around. Look at that. Cool. So what is happening is the camera is actually going along that slider from one end all the way to the other. Okay, and by the way, this path can be anything. It can be like a bunch of lines and arcs. It can be a spline. It can be anything. But in this case, since I want it to be like a turntable animation, I'm going to use a circle. And all I've got to do now is just go to the 0-second mark and save it. And in the animation, I'm just going to change it to 100%, and that's it. Before I do that, let's go with like 1:1, maybe like zoom out a bit. So we'll use like a wide angle, something like that. Here, okay. And now back again into my motion study. All I've got to do now is, in the beginning, I would add that camera. You know what? I've got another idea. How about this? What if I want it to start from the very beginning with my camera? Okay, so you've got two options. If you're outside of the camera view, then you have to do what I previously showed, which is to right-click and add the camera view inside of the motion study and stuff. But if you're in the model view and you start the camera view, okay, I'm already in the camera view. Now, if I create a new motion study, it's going to default to whatever is on the screen right now, which is actually the camera view. Okay, so it's actually just like saving me a couple of steps along the way. I don't need this sketch anymore, so I can just hide that. So I can hide it from over here just like that. And now back again, all I've got to do is come to the 5-second mark, open this folder, change the properties of this camera from like from the 0% all the way to 100%, and call it a day. I'm just gonna hit OK. I've got this change bar, and I'm gonna hit calculate, and there it is. And now look at this y-axis. It's staying where it is. I'm actually rotating about it, and the shadow is perfect, pristine. This is what I would call a true turntable animation. And you know what the cool thing is? Let's say, for example, oh, I actually need this to be 10 seconds long. Okay, just drag this to the 10-second mark. And just like that, if I hit play from the beginning, it's going to work for 10 seconds long. If I want to change it like 2 seconds long, well, no problem. Drag it all the way to the 2-second mark, calculate once again, and there it is. So you've got 100% full control over everything, and you can easily edit it without being like afraid of messing something else or deleting something else by mistake. Okay, so yeah, that was pretty much it. Let's get it back again to like 5 seconds, because that's more sensible. And that's when it comes to the rotation. Okay, and as I said, here's the side-by-side. So the one on the right, this is the one we created with a slightly longer method with like the camera and the path and everything. The one on the left, that's the one created with the animation. And only in this situation would I would actually prefer the one on the right. But as I said, it's up to you. If you want something quick and dirty in like under 10 seconds, you know how to do it. If you want a bit more prep and you want it to look a bit better, like the one on the right, you also know how to do that. Okay, now let's take it to the next level. We've created the rotation or the turntable animation. Now how about doing some exploded views? So in case you don't know, exploded views, if I go back again to the model view over here, they exist here in the configuration manager tab. So if I switch over there, I've got like configurations, but I can also right click and add a new exploded view. And in that case, I can like move certain components and explode them to show you how something is like being put together, or the different components inside of something, and so on. So I've already got one over here. I've got exploded view, and one might say, okay, what's so special? I can go over here and hit animate explode, and there it is. It's going to animate. And if I pause, I've got this save animation button to save it. There's nothing special right now, but this will only save you this exploded view animation on its own. Let's say you want to incorporate this or add it along with something else. You want to hide some components as well. You want to change the camera as well. You want to do something else alongside the exploding or the collapsing animation. How do you do that? Well, you actually import this inside of your motion study. So this is what we're going to do right now. So once again, let me just right click and collapse. So this is the way it was. I'm going to go back again to my motion study, and back again over here to the animation wizard. I'm going to go to the explode or collapse. First things first, let's go with explode because that's the beginning. And I'm going to go next. How long do you want it to be? Let's say, how about 5 seconds? Okay, start time 0 and hit finish. And just like that, a couple of clicks away, and I've got all of these key points added for me. Now, when I hit play from the very beginning, I actually didn't put this at the 5 second mark. Here is the 5 second. Now let's play this from the beginning. And while it's actually rotating, this is actually exploding at the exact same time. It looks super cool, right? But you know what's going to make it even more cool? If I actually do a collapse after that. So if I start at the 5 second mark, and then from there, I'm going to add another collapse. I'm going to put the time bar at the 5 second mark. I'm going to go over here, add a collapse animation, hit next. And since I'm already at the 5 second mark, it understood that the start time would be at the 5 second mark. The duration is also 5 seconds, just as it was for the explode. I'm going to hit finish, and it like mirrored all of these key points back again. And for this camera, let's drag it all the way to the 10 second mark. And just like that, if I hit calculate, let me just make this a bit smaller, just so you can appreciate how it actually looks. So as you can see, I've got the collapsing, and after it finishes, it's going to explode once again. Maybe if I would rethink this, I might add like a small pause between the collapse and the explode, just for eyesight and stuff, to make it easier on the eye. But the rotation is happening simultaneously. I can hide, I can show, I can change appearance. I can do all of these things in the exact same timeline. Okay, how cool is that? So that was super cool when it comes to adding all of these things in an animation. But let's take it to the next level, because there is still some more awesomeness. So how about make controllers? So make controllers, from their name, well, what they do is they control mates, right? And when you think of it, this tool was added back in like 2016, I believe. Okay, so that's like what, 6 years from now, or 8 years from now, right? And maybe even longer. And you don't usually find many people talking about this tool, even though it's one of the best tools, in my opinion, to control a big set of mates. Okay, so how does it work? Let's start by the very basics. You go to the Insert tab. From there, you've got Make Controller. You hit it, and you've got this Property Manager over here. What I'm going to do right now is to add mates to my mate controller. I'm going to add mates that I want to control. I can select them manually, or I can click this button to automatically collect all the supported mates by the mate controller. And we're going to talk about what mates it supports later on. But just right now, I'm just going to hit calculate, and it got all of these. Forget about the names. These are actually limit angle mates. I just renamed all of them just for my sake. But these are all, as I said, limit angle mates. So if I scroll a bit down, now I've got all of these limit angle mates listed with numeric control over all of them. Okay, so let me just give you a couple of seconds to make this sink in. I've got control over all of these mates at the exact same time. So let's say, for example, I want to add a new position. I'm going to click on this Add Position button. And from there, here's the new position. What I'm going to do is, let's say I want all of these to go downwards. Okay, so I'm just going to change this from 90 to 0. I'm just hitting the Tab button in my keyboard to go to the next one. And just like that, in a couple of seconds, I've got everything downwards. You know, I've just changed 16 different mates in like under 2 seconds. I'm going to hit the Update Position button. And just like that, I've got the new position updated. So position 1 is everything upright. Position 2 is everything downwards. Okay, let's say I want to add a new position. Here's position 3. And let's say I want 1 up, 1 down, 1 up, 1 down, alternating. So I'm just going to change this right now real quick. And remember, all I'm doing is just using the Tab button in my keyboard to change these. Okay, and I've changed all of these, update, and that's it. I've got position 1, 2, and 3. But did you just notice what happened when I hit the Add Position button? It actually duplicated the position I'm in. So let's say, for example, I want everything to go back again to the very beginning, the first position. Well, why don't I start from there and hit Add Position? And in this case, position 1 is going to be a perfect copy from position 4 is going to be a perfect copy from position 1, but added at the very end. So I'm going to hit OK. And just like that, I've got 1, like that, 2, everything downwards, 3, alternating, 4, everything's back up again. Just like that. I didn't even have to change everything myself. And let's say, for example, you want to reorder these later on. Well, from over here, you can reorder these positions. So I can say, okay, let's change position to move it up, like over here, move it down, stuff like that. I can rename them, I can delete them, got full control over all of these. So let's keep it at this, just for time's sake. And if I scroll all the way down, now this is the very important part, which is to set duration for all of these. When it comes to the exploded view or something like that, I didn't actually have to set the duration while creating the exploded view. But here, I actually have to set it in here. So let's say 1 second each. So from the first position to the second position in 1 second, from the second position to the third position in 1 second. And let's say I want it to go back in like 0.5. So it's going to be a bit quick at the end. No problem. Okay. After that, I can also save it from here. But if I want to incorporate it in my animation, then I'm going to have to insert it or import it with the animation wizard. So I'm just going to hit OK. And before I go over there, let me just rename this just to make sure I'm not confused. I'm going to call it like Make Controller Polkflswug. Okay. And by the way, quick tip: if you go over here and click on it, you've got this, which will actually allow you to change these positions while in the assembly itself. It's super cool. Okay. Anyways, let's go back again to position 1. I'm going to create my new motion study. I'm going to go to the animation wizard. And now I don't have any exploded views created here. So these two are grayed out. But I now have a mate controller created. So I can select that one. Go next. I'm going to select this one. And it's telling me, okay, how do you want to import it, as key points or as motors? And it even tells me, okay, for animation, use key points. For motion analysis, which is the third type of motion studies that we won't use, it's going to be using motors. So I'm going to stick to key points for now. Hit next. And you see, the duration is grayed out because it's already predefined inside of the make controller. All I can do is just set the start time, hit finish, and call it a day. But where is everything? I can't see anything over here. Well, that's actually because these are mates that we're controlling. So if I go all the way down to the mates folder and open that, now I've got all of these created in just a couple of clicks. Okay, so now all of these were just created in the couple of minutes that you saw before. If I want to actually do these by hand, that would take ages, like double click on each one of them and changing the dimension and going to the other one and so on. But now I can just hit play from the beginning, just like that. Everything is going downwards, and then some of these are coming up, and then all of them are coming up once again. So just like that. And that was done in the matter of minutes, you know. And you can take this back to the next level. So for example, this is another one that I created before. I'm also going to collapse this just to make it as big as possible. Look at this. So these two get down like as handlebars if you want to. And then, you know, this wave. So I actually did create this as well over here. And it obviously would be a nightmare to create something like this wave if I was doing this manually. But because of the make control, it was very easy to create it on its own while controlling all of these different mates in one go. Okay. So yeah, that's the make controller. So before I forget, now let's talk about what the make controller actually supports when it comes to different mates. Okay, so these are the mates that it supports. It supports the angle and the limit angle, the distance and the limit distance mates. It also supports some of these, they're called advanced mates, which is the width mate, the slot mate, the path mate, and so on. And here's something to note. These last three, the width, the slot, and the path mate, they've got different options. They can be free, they can be centered, and they can be numerically controlled by like a distance or a percentage. Only those numerically controlled are supported by the mate controller. So anything that is not able to be controlled by a number or a value, it won't be supported. Okay, so that's something else to keep in mind. Okay, so that's actually it when it comes to animations. Now let's talk about basic motion, which is the other way. Okay, as I mentioned, it's a bit more like it's got like physics based in it. So let's talk about how we can actually incorporate physics inside of our animations. So I've got the model over here. Let me just open it real quick. And remember, what we're going to do right now is not something that you can create with animation. It has to be done with basic motion. So this is the model I've got. It's called a wave motion simulator. When you rotate this handle, these red dots over here would get closer and away as if it's like a longitudinal wave. And these ones over here would move like in a sine wave as if it's a traverse wave. So we've got both types of waves generated by this same contraption. It was a really cool thing I saw at the lab back when I was in school. So I'm going to create a new motion study. And what I'm going to do is, it's going to be pretty simple. I'm going to start by adding a motor. And that motor is going to be on this axis. So let me just zoom in a bit and select something like that. Okay, the direction, I want it to be this direction. The speed, once again, I don't like doing math. So 1 divided by, let's say, 60 divided by, let's say, 2. So it's going to be in 2 seconds. Because as I said, this has got like some physics calculations in the background. So I don't want it to be like too long. Okay, so I've got the motor, and let's end the animation at 2 seconds. Okay, now that looks cool. What I want to do now is add the contacts. Okay, and the contacts can be found over here. There it is. So this is the contact button. If I'm going to hit the contact, the first thing you notice is this pop-up. It tells me the tool you've chosen requires the use of basic motion or motion analysis, because right now I'm actually still in the animation type. So from this drop down, I can actually change it to basic motion. Okay, I'm using actually a student edition, so I don't have, it's the standard edition of SolidWorks, so I don't have a motion analysis. If I did, it would be the third option over here. So I'm going to switch to basic motion, and just like that, everything is going to work just fine. So what I have over here is I've got the contact types, solid bodies. That's what I'm going to use. I've got the selections. And in this case, what do I want to calculate the contacts between? In this case, I want to calculate the contacts between all of these different cams or discs and all of these rods or bars. Okay, so let's select all of these. I'm going to open the tree over here. I'm going to select all of these. Just like that. And remember, the software is going to calculate the contact between all of these, or the possible contact between all of these. Even if they don't actually collide with each other, it's going to expect one, right? So how many calculations are going to do? Well, 561 contact pairs. That's a big number. But okay, I mean, that's what I want to. So I'm going to hit OK. And I've got that contact over here as well, solid body contact. Now let's just hit calculate, sit back and watch the magic happen, where based on this, everything is going to work just like that, you know? And you know what? There's, as I said, something else that I forgot to do, which is this was actually originally set up for an animation. So I had some mates that I didn't suppress. So let me just suppress those mates first. We'll go over here, even in a folder, 100 mates, and just suppress all of these. So now I'm going to force it to actually calculate everything using the contacts and the physics and all of that stuff. So no tangent mates, nothing. Now let's hit calculate once again. This time it should work perfectly. And as you can see, the rods are rotating. But what's happening here? Okay, I should have expected that. Well, technically it's not wrong, because these are actually hitting the rods, and the rods are being pushed upwards, but nothing's actually telling the rods to come back down again. So we actually have to tell the software, hey, there's something called gravity. Ever heard of it? Let's add that as well. So gravity is something on its own over here. It's got its own property manager. So here it is. And you know what? Let me just change the background to something lighter so that you can see this next part a bit better. Let's make it like white. Okay, so when I go again and add some gravity, you notice this green arrow over here at the very right? This is the direction of gravity. Since this is a software, I can put it any direction. I can say, okay, I want the direction to be X, to be Y, upwards, maybe, if that's what you want. You can choose anything. You can even choose like a thing. So I can select like this edge of the model to be the direction of the gravity. I can do anything. But for now, let me just go with the bottom direction with Y, okay? And by default, it defaults to the G of Earth, which is 9.8 something, the gravity acceleration of Earth. So I'm going to leave everything as it is. And I also see I've got the gravity, so I've got the motor, I've got the contacts, I've got gravity, I've got everything I need, and that should be it. So let me just zoom out the camera a bit, because it's a bit zoomed in. Okay, now when I hit calculate, I should have everything set up. So I've got the motor to rotate the rod. I've got the contact to calculate everything between the cams and the rods. I've also got the gravity to make sure everything comes down again. And just like that, as you can see, everything's working perfectly. Okay, so that's just it. It took me a bit more understanding of what the software expects from the physics-based things that I would use. But just like that, I've got everything set up right now. And now let's like see a conclusion of what we just created. We got the contact to calculate everything for us. But let's say we actually want to reduce that calculation. Let's use something called contact groups, which is to group these things together, these calculations together, and reduce the solving time. And when it comes to contact groups, the keen eye of you would have noticed this option over here. So if I right click, let me go back again to my solid body contacts. I'm going to right click and edit the feature. And from here, I've got this use contact group option. So remember, the previous number was 561. I'm going to clear all of these. I'm going to go once again and use the contact groups. And now I've got 2 boxes to enter in, not just one. And there's a note over here. It tells me, okay, contact between items in the same group is ignored. So that means that, for example, I already know that these rods actually move in a certain opening for them, so they actually won't collide with one another. And these discs, they're evenly spaced from one another. So they would never collide. So I know that I don't need to calculate or expect the calculation of any contact between these disks and each other, or these rods and each other. So how about I add each of those into its own group, so that in that group they don't calculate, but when some item in the first group is calculated with the second group, that's only what SolidWorks would actually calculate for me. So in the first group, let's go with all of the rods. Let me just, the background. I'm gonna go back again and make it a bit darker. Yeah, go back again and edit the contacts, and I'm gonna do the same thing. So I'm just gonna use contact groups. In the first group, I'm gonna put all of these cams, or these circles, and in the second group, I'm going to add all of these rods. And just like that, let's see the new number, 289. That's like what, 40% reduction. So I've actually saved a lot in the number of contact pairs, and it would actually calculate a lot longer. But what about the end result? What do you expect? Do you think it's actually going to give me a new result? Well, how about we see it for ourselves? So over here, I've got ungrouped on the left side and grouped on the right side. Okay, and to the naked eye, to my eye actually, I don't see any difference, and that's the truth, because in reality, whatever contact that would happen is going to be calculated. The only thing I told it is, okay, these are contacts that would never happen, so ignore them. So it just would calculate a bit faster. So that's why you would not see any difference in this case. But let's say, for example, there were actually contacts happening between those components, and you wanted to ignore them. This would be the best way to do that manually. Okay, and just for fun, I did this also comparison with mates. So the one on the left is one used basic motion, and the one on the right, this was using the tangent mate, or the cam mates in SolidWorks. So this is actually an animation, not basic motion. And when you compare both of them side by side, I actually think that the one on the right is actually smoother. The animation is smoother, but realistically, is it actually going to be that smooth? And this is actually a question to you. If you want something that's like realistic, well, then you need some simulation in it. You need some physics, you know. So in that case, you would go with basic motion. If you want something that looks hyper cool, hyper realistic, and in that case, you don't want any hiccups, any friction, anything. You want something that's like frictionless, in like no problems at all, no dust, no nothing. Well, in that case, you can use the animation. Okay, but this is not one solution or one fix for all, and keep this in mind. But first of all, let's talk about gravity first, because there's a bit more that we haven't covered. So what we talked about gravity is that the direction is really important, but note that gravity can only be added once in your timeline. So I can add multiple contacts between different types of components or different sets of components, but when it comes to gravity, there can only be one gravity force in your timeline. And gravity is actually overridden by any force that you add, whether it's like from a motor or something like that. So if like a gravity is pulling something downwards, but you added a motor to push it upwards, it's actually going to go upwards by that motor. So that's also something to keep in mind. Okay, so back again to what I was saying, which is if you want to create something in animation or basic motion, not always is it actually possible to create it in both cases. So for example, look at these. So these are all things that could not be created with animation. They can only be created with basic motion or motion analysis, because there's a level of calculation here based on physics and real life simulation that you just can't mimic with the mates and the cameras and the stuff that we showcased earlier. Okay, each one of these is based on something that, to be honest, I can't use. And I've been using SolidWorks for like 8 years now. I can't do something like that in an animation. So it's always good to know what the capabilities are of each type of these, and also know what you have in mind. What do you want to do? What's the end result that you want to accomplish? And based on that, choose which one to go for. Okay, so that's pretty much it when it comes to animation and basic motion. Now let's talk about some tips and tricks for exporting. And the first thing to remember, which is something I like hinted before, which is when you've got an animation like the spring that I showed you, where the geometry itself is being rebuilt on every single frame, well, that would actually take a lot more time to calculate when it comes to the motion study. And another example is this pull and ratchet mechanism you see on screen right now. And something else to note, which is those animations, when you try to render them with PhotoView 360, for example, or SolidWorks Visualize, they won't actually be rebuilt on every single frame. It's only going to stick to the very first frame and render the whole animation with the model in that shape of the geometry. It's not going to support multiple ones. So if you save it or export the animation with SolidWorks, with the SolidWorks screen as the renderer, only in that case would you actually be able to show it being rebuilt on every single frame. Okay, one more thing to take in mind, which is animations don't only have to be saved as videos. You can also save them as images, like still images. Every single frame is saved as its own image, whether it's like a PNG or a JPEG, stuff like that. And that can be really useful. Let's say you want to do some like image manipulation or like some graphic editing, or maybe you want to create a GIF. And yeah, I do actually call them GIFs. So you can use images for that. Let's say you want to grab a certain image or a certain frame from the middle of the animation to use it as a thumbnail for your video, and that's something I've created before. You can also do that. Okay, so these are the different ways you can export. And one more thing to note, which is there are two main things to consider when you're setting or specifying the options to export. You've got the resolution and you've got the FPS, or the frames per second. Resolution is the number of pixels in the width of the image and in the height of the image. So let's say HD, high definition. That's 1280 pixels wide by 720 pixels tall. When it's like full HD, that's 1920 by 1080 pixels. So the more pixels you add, that means that you've got a higher resolution. And in that case, you're going to end with a more clear image or a more clear video. But obviously, the file size is going to be a bit bigger. And the other thing is FPS, or frames per second. How smooth do you want your animation to be? If the FPS is way too low, it's going to be like a choppy animation. It's going to be like stuttering. But if it's very high, it gets a bit smoother and you don't notice the stutter, because it's like going from one frame to the other very smoothly. And it's doing that many times in 1 second. Okay, the last thing I want to talk about is video compression. Okay, and I know we're actually getting really close on time, so I'm just going to end with this. Video compression is when you want to minimize the size of the end result of the video that you export from SolidWorks. Okay, so let's say you've got like a 10-second animation. You don't want to end up with 1 gigabyte of video files. You want to be as small as possible, right? Because it's just 10 seconds of video. So when it comes to video compression, it affects two things. You've got file size. Obviously, that's the end result, but also the exporting time, because there's an algorithm that's working in the background to actually compress all of that just for you. So this is actually a comparison that I've got over here when it comes to video compression. So this is the exact same video. The only difference here is the different types of file formats and video compression, okay? So I'm going to play it right now, but keep an eye on all of these three different video compressions. The one on the very right, this is the MP4 file format. The one in the middle, this is a fully compressed AVI file format. And the one on the left, that's an uncompressed with no compression whatsoever, okay? So here it is. And by the way, what you're seeing on screen, that's not stuttering because of the laggy internet connection or PowerPoint is not being able to render the video correctly. No, this is actually what I got from the video file when I saved it from SolidWorks. It looked that bad, okay? So it's the exact same animation. Nothing changed. The same key points, the same motors, the same everything. The only thing I changed was the exporting method, the options or the settings that I used while exporting. Okay, so now let's take a deep look at this. So I've got the model open over here. Okay, I've got this one, and here's the motions that I was creating. So in there, I can go and click on this button to save the animation. And from here, I've got this dialog box, which tells me, okay, set the file name, stuff like that. Save as type, this is the important one. So the first couple of ones, these first 4 ones, these are video file formats. You've got the AVI, FLV, MKV, and MP4. Anything that's called series of, that's an image file format. So you've got series of bitmaps, PNGs, JPEGs, and so on. So these are all images for every single frame. So actually a fun fact, PNGs are one of the few image file formats that support transparency. So if I actually close this for a second and go over here to the options, this is actually a very neat trick that I've used before. So I can go over here and go to export settings. And from here, I'm going to go to this one, TIFF/PSD, JPEG, or PNG. And I can actually say this remove background option. I'm going to check this, okay? And now when I save this animation as a PNG, remember, I've got this dark gray background color. So if I go to a series of PNGs, let's save this to my desktop real quick. I'm going to call it Polkflswug. And before I keep going on, so with the renderer, it's SolidWorks screen. If I had like Photo V360, I can choose that from here. I've got the aspect ratio and the resolution over here. So in this case, if I'm using a camera, it can use the camera default aspect ratio. If I want to use a custom one, I can specify it from over here. So I'm going to go with 16:9, and let's go with like HD, so 1820 by 1280 by 720. And here is the FPS. Now remember, 7.5 is the default for now. Never use 7.5. Use anything. You can use 24, 25, 30, 60. I believe that in America, the television used to broadcast at like 29.97. Use that, but just don't use 7.5 because this is way too low to look good on any device, whether it's like a phone or an image or a device like a laptop or even on social media. It's way too low. So I prefer to use 30. And if I need the smoother animation, I will go to 60. Probably never go higher than 60 and never below 30, okay? So I can say, okay, I want to export the whole animation or maybe just a small time range of it, or maybe as like a single frame. So in this case, let's say a time range. I've got 30 frames per second. So if I save the animation from 2 seconds to 3 seconds, that should save 30 different images for me. Well, that's way too much. So let's say like 2.5. It's going to save like 15 images. That would work. I'm just going to hit save. And it's going to go through those. And if I go over here to my desktop, I can actually see all of these images getting created. And note something, that these images will have no background because these are PNGs. And as you can see, there is no background. This is not white. This is transparent pixels. Okay? Because PNG, as I said, it supports transparency. So this is actually a very neat trick to use. So that's with regard to images. Let's talk about now video formatting. So if I go to AVI, for example, because this is the default, that's why I'm talking about it. Let's set this, let's save everything as it is and just go with the AVI. If I hit save, it's not going to save all right away. First, it's going to ask me what compression do you want to use. So here I can use, okay, different codecs or different algorithms for compression or full frames, no compression whatsoever. And if I go with one of these, I can change the compression quality by the slider to change the ratio. The default is like 885, so that's a good value. If I hit OK, it's going to start exporting frame by frame and so on, and making the video for me. I can hit stop over here, and that actually means that it did create the video for that duration that I let it go before I stopped it. So I did actually end up with a video file. It's not going to be corrupt or anything. But what happens when I do it in an MP4 file format? So if I go to MP4, I'm going to leave everything as it is. When I hit save, it just goes ahead and saves for me. It doesn't even ask me what compression do you want, because MP4 knows what's better for me. So it's going to do it on its own. Okay, so now let's stop. And once again, just as I said, I already have the video created for me. It's going to be whatever duration that I let it go before I stopped it. It is actually a working video, so I can actually play that, as you can see over here. Okay, it's going to work all up until the I hit stop. So that's good to know as well. But now let's talk about numbers. So the uncompressed AVI, that one was 292 megabytes for a 4-second animation. That's more than quarter a gigabyte. Can you imagine that? That's way too much. On the other hand, the fully compressed AVI, it was about like 1.5 megabytes, way smaller. But when you saw the comparison earlier, well, the quality was rubbish. So take it with a grain of salt. When it comes to the MP4, well, look at this. This is 23 kilobytes. I'm not talking about megabytes. No, it's kilobytes. I'm taking it one step further. That's like 1,000 in difference between both of them. So this is a totally different unit. And to me, the uncompressed AVI and the MP4 looked identical. But when it comes to the difference in file size, wow, it's massive. So personally, I never used any file format when it comes to video other than the MP4, because from what I've seen, MP4 just strikes that balance between file size and the quality. In case you need to have a certain value of video compression for whatever reason, well, in that case, you can use the AVI. Other than that, ever since SolidWorks introduced MP4, I think that was like 2020 or 2018, something like that. I've been using it ever since, and it's been perfect. Okay, so I know we went a bit over time, but I hope that was worth it for you guys. And with that being said, that's all for today. That time for a Q&A. So I'm gonna check the chat right now to see if there's any questions. But just a quick note: if you have any questions later on, feel free to send them to me. Or let's say there's a question we didn't get to talk about today. You can scan this QR code. It's gonna take me to my LinkedIn. Feel free to reach out with a message over there. I've got an open profile, so anyone can send me a message, even if we're not connected. Just send me a message, say, hey, I was at this user group meeting, and it doesn't even have to be a message. If you've got like an animation that you created, I would love to see it. So post it on LinkedIn, tag me in the post, and tag Amy as well. I would love to see those creations as well. And for now, I'm going to go ahead and look at the chat for any questions.
I love Audie. Audie, do you do animation? You seem to know a lot about the terminology.
Yeah, actually, I did animation not in SolidWorks. I used Premiere, Adobe Premiere. I used 3D Studio Max. So I had some history with the animation, not anymore.
Yeah, cool. I see you adding some info in the chat.
I'm seeing Premiere and Photoshop, and I'm like, oh, I know those things because I work with Adobe I play with Adobe along with SolidWorks. So yeah, I was like, okay. Yeah, what is an alpha channel?
Oh,
yeah,
alpha channel.
Alpha channel is basically the transparency level of your image. Okay, so every still frame is an image file, right? And that image it's usually created of RGB, red or green or blue. Some file formats support another A value, which is alpha value, which is also from 0 to 265, 255, just like the RGB, but that indicates the transparency. Okay, how transparent is that pixel, or how opaque is that pixel? Okay, not all file formats support it. So bitmaps or JPEGs, they don't support alpha channels at all. Okay, but when it comes to PNG, it does support it. So that's really cool because you can have something and not be the whole resolution full of pixels. Maybe some of it is the image and the rest is just transparent. So if you put it on top of something else, whatever is behind it is actually going to show through those transparent pixels. And if the pixel is semi-transparent, it's got an alpha value of like 128, which is like 50%, it's going to show half of the value of whatever is behind it, and so on.